So welcome to this public forum, Surviving the Heat. So I'm Tsz-cheung Lee, the former director of the observatory and now with Hong Kong UST. And of course, the other moderator, Professor Alexis Lau, is also sitting here, and he will moderate the second panel, and I'm moderating the first panel. So without further ado, may I invite our three panelists to come out and join me and to dive into the first simply a science panel. So first of all, Professor Sarah Perkins-Kirkpatrick from Australian National University. Welcome to Hong Kong. And the second panelist is Dr. Tsz-cheung Lee, my former colleague, now our chief scientist on climate change. And third but not the least, Professor Winston, Associate Professor of Hong Kong UST. So without further ado, Sarah, please go ahead. Each panelist will first brief us for 7 to 10 minutes, and then we will open up for discussion. Thank you.
Good afternoon, everyone. Thank you very much for attending this afternoon. And also thank you very much to my colleagues for hosting me in this glorious city. So this afternoon, I just want to take you through some of the knowledge, the scientific knowledge behind changes in heat waves or extreme temperature events. Oops, and that shouldn't be the end of my presentation. Start at the beginning. Now, I don't think I need to tell you about how extreme the heat's been in Asia recently. You've had, particularly in Hong Kong, you've had one of your warmest Aprils, if not your warmest April on record. This follows from what happened in April last year, and it's also not just been in your wonderful country. It's been all over Asia. Not only has it been hot, but it's also been terribly humid. And heat and humidity combined can be quite dangerous to human health and also just be not a good situation to be in. So I'm not going to go through every picture in this slide, but I just wanted to show you some of the record-breaking extreme heat that's occurred in this part of the world this year around this time and last year around this time as well. So it's really been quite something. And as a climate scientist who studies these types of events, even I find them quite shocking how much is happening and how quickly. Because of the extreme events that we are starting to see, and there is a strong tie to climate change, which I'll come back to, we are seeing more of the global population be exposed to these extreme temperatures. Now, as the climate continues to warm, we will see even more people being exposed to these extreme conditions. And what this figure is trying to show us is, as the planet warms, just how many people will be exposed. So, for example, if we warm by 2 degrees Celsius, there's a 67% chance that over 100 million of the world's population will be exposed to extreme temperature events. The higher the number of exposed people does decrease, but it certainly does increase this increase in climate change. Now, when this paper was actually written about 7 years ago, the current climate was roughly at about 1.1 degrees Celsius. And for those of you who have been following the latest news, we're actually currently sitting at 1.5 degrees Celsius just in those 7 short years. So you can see here already we're starting to see increases of people being exposed to this, to particularly extreme events. So coming back to one of my main points is climate change is the main driver behind these extreme temperature events. There are other physical mechanisms, and I'm happy to talk to you more about those another time or even over coffee a bit later. But the changes that we've been seeing recently are largely and almost always driven by climate change. And this is because we only need a small shift in average temperatures, and here I'm talking about globally average temperatures, to see a large change in the frequency and severity of temperature extremes. It's actually a really simple relationship, and one of the most simple relationships when we're talking about climate change and changes in extreme weather events. Now, as a globe, we've warmed by 1.1 degrees Celsius since 1950, but roughly we're sitting at 1.46 to 1.5 degrees Celsius, depending on what data set you look at. And this is because of us. It's because of us putting more carbon in the atmosphere since the Industrial Revolution. So what does this mean for heat waves generally across the world? Well, looking at observations, and we generally go back to 1950 when we look at global observations, because that's basically how much that's the starting point where they become of good quality. Excuse me. We can see that the number of heatwave days are increasing basically everywhere in the world. Almost nowhere is, protected from these trends, particularly if we look further into the future, look into trends that are finishing about now. And also because of that, we're being exposed to more heat. The more heat wave days we see, the higher temperature anomalies we experience, which is bad for not just human health, but many other industries, agriculture, cattle, you name it. You'll be affected by extreme heat. No industry is protected from extreme heat, as is no living animal or human. So future projections of extreme heat, how we do this, and I think my colleague will go into this a bit more in the next talk. When we can look at future changes in heat waves, they actually scale quite closely to global warming. So once again, the more the planet warms by, the more heat wave days we'll see, the hotter the heat waves will be, the longer the heat waves will be, but also at the same time, depending on where you are in the world, the number of heat waves we see in a season will change in one of two ways. So firstly, if you live in the higher latitudes, kind of like I do, you see a stark increase with per half degree of global warming. However, if you live in tropical climates like here, there becomes a time at roughly 2.5 to 3 degrees Celsius where heat waves start to join up. It becomes one long hot summer. And I don't need to tell you about what that means in a climate, particularly this climate where humidity is such a big component. It really is quite concerning. So basically, limiting man-made climate change will help slow this down. Okay? The relationship is different depending on where you are in the world, but the relationship is there. Okay? More global warming, hotter heat waves more often. So locally in China, this paper came out quite recently. It follows a similar pattern that you don't really forget all the fancy statistics and names that we've got here. But basically what this plot is trying to show you is for every region in China, all heatwave metrics increase. And the higher the emission scenario, so that once again, the more carbon dioxide we put into the atmosphere, the larger those changes will be. Okay, so it's just reiterating this point that nowhere is immune. And even when we go down into sub-regional scales over this part of the world, those changes are quite stark. And there's larger changes at the end of the century relative to in 20 or 30 years' time. So these plots, I'll explain them. I'll go into a bit more detail. But this is basically showing what heat waves look like where I live, and also compared to China as well. Now, each of these maps, you can hopefully see two tiny crosses, or one tiny cross there that have actually been expanded upon here. Now, in the case of the Australia plot, that was our bad summer that we had a few years ago, and it's showing just how hot those temperatures were. Every other dot above that is a projected heat wave from climate models. And what it's basically saying is that in one of our likely futures where we might warm by 3.5 degrees Celsius, we will see heat waves that are far worse than anything we've ever experienced. This was our worst summer on record. Now, similarly, we looked at a heat wave over China in 2017. I don't think it hit Hong Kong particularly badly. It was more in the northeast. But once again, you see that same regional pattern, that observed event basically is nothing compared to what's coming. And even if you look at scenarios where we only warm by, say, 1.5 degrees Celsius, which is roughly now anyway, even up to 2 degrees Celsius, this still happens. You still see this pattern. There's less of it. It is a better world, but you still see heat waves that are worse than what we've experienced. Okay? And this is something that's quite concerning. It's basically saying that, limiting global warming is fantastic. We absolutely need to do that, but there's ultimately going to be things that are coming that we haven't yet, we're possibly not prepared for and haven't yet experienced. Similarly, heatwave events that are coupled with humidity are also on the rise. And this study showed that if you look at an event that occurred, if you look at the black event, a 1 in 500 year event, that's an event that occurs on average once every 5 years. It's meant to be very, very rare. There's almost no risk at the beginning of this century, but when you move into a climate where that warms by 2 degrees Celsius, that risk is much higher. So what was an exceedingly rare event that many of us would not experience during our lifetime is something that is experienced maybe, somewhere between 2 to 10 times in our lifetime. And lastly, I just wanted to talk about days that are basically non-livable because of this deadly combination of heat and humidity. And it actually depends on your age. It probably also depends on your gender, but we don't actually have the statistics yet to prove that. What these maps are showing are, once again, by different global warming thresholds, days that basically thick people can't survive in because of the human physiology and how that interacts with heat, or sorry, how heat and humidity interacts with that. So if you're young-ish, so up to 40 years old, you do have a better chance of being able to survive in those hot and humid conditions, even in a world where it's 3 degrees warmer. Sure, yes, there are certain parts of the world where you do see days that aren't physically survivable, but the effect is much worse if you're older. Now, this is for the end of this century, and I will certainly be over 65 by the end of this century, so I'm personally quite worried about these projections, that where I live, and even over large swathes of the Northern Hemisphere. Now, once, as I showed on a previous plot, we're going to warm probably by at least that amount. And if you're outside and over 65, you're going to be exposed to conditions that simply aren't tolerable based on your physiology. Now, there are ways we can adapt and mitigate towards this. I don't mean for this to be so doom and gloom that everything's going to collapse, but it's something that we need to be really cognizant about moving forward. This is what's coming, and we have to be prepared for it. And with that, I'll leave my presentation there. Thank you.
Thank you. Actually, when I first saw Sarah's last chart about survivability, I was really concerned because I'm already approaching 65. But when I asked Sarah, how about 80? We are not looking good even for South China. So thank you, Sarah. And then
we're here now, so
yeah.
You're doing a bit better now. Maybe not so much in 50 or 60 years, but yeah, we're all right for now.
So then I'd like to hear from TC. Are we going to survive in Hong Kong? Thank you, Sarah. And TC will talk about our climate projections for Hong Kong and also how we are warning them.
Thank you. First of all, thank you for Hong Kong University to invite me here. And actually, this is my pleasure to have meeting so many old and new friends here, including 2 former directors of Hong Kong Observatory. Two, right? 2? Any more? Okay.
And also former Secretary for Environment.
I know, I just want to say. Yeah. Anyway, all are good and old friends. Today, I would like to share a quick overview on the extreme heat. That's called emergency conditions, but we have the backup here. I would like to share the extreme heat in Hong Kong, and just a very quick overview on that. Before that, I need to tell you that why we need to have this night, because we have to monitor the temperatures before we can actually note what is the changing of the climate. And one of the important stations in Hong Kong is the Hong Kong Observatory headquarters. If you have been there, you should see the photo there. It is we have a business start at 1883, so that we have over 140 years of data. So it's important for monitoring the climate in Hong Kong, actually for part of the world. And Mr. Cian here, he is the one who received the certificate from the WMO to recognize the observatory headquarters as one of the centennial stations in the world. And besides that, we also have the King's Park meteorological stations that give many observations here, including Upper Air Station. And since the mid-1980s, we start to have the automatic weather station network that cover a wide range of areas of Hong Kong that tell us the regional difference of temperatures in Hong Kong. And about extreme heat, how hot Hong Kong can be so far. Actually, this is the ranking of the hottest days in Hong Kong. I'm referring to the Hong Kong headquarters, Hong Kong Observatory headquarters. And actually, you can see that the highest temperature so far we can achieve is 36.6, and not very far away, just 2017, due to the Super Typhoon Hato. And you see that the top few ranking, most of them are usually related to tropical cyclones. This is the typical situation in Asia, because in southern China, because the substance that enhance the heating the day and make the weather very stuffy and difficult to survive. Okay, this is the case. But actually, over some areas in Hong Kong, for example, the New Territories, the temperature can go even higher. If I am not wrong, the highest temperature I ever find is 39 degrees in the Wetland Park. Okay, and
Tsz-cheung Lee as well, I think.
Tsz-cheung Lee as well, yeah. And so I'm expected with the warming going on, we are not far away from 40 somewhere in Hong Kong. Okay, just my prediction here. And for the warming in Hong Kong, you can see the temperature trend. And actually, the warming in Hong Kong is not just due to global warming. We have very significant urbanization over the century. So together we have a very similar trend to the global trend. But our warming rate is a little bit higher than actually higher, not a little bit, higher than the global trend. And so as explained by Shara, that we have a dumbbell distributions. So if you have a very small shift of the mean temperature, the extreme end will end up with a non-linear increase in the extreme temperatures. This is the examples of what we see of the hot nights in Hong Kong. The very hot days, we're referring to 33 degrees Celsius. And recently, we have another class of extremely hot days, 35 degrees in Hong Kong. And this table shows you the difference between the recent 30 years and the 30 years back in the last century. So 100 years difference, you see the multiple times, not multiples, over 20 times more for the very hot days and hot nights, and for extreme hot days, it's also over 20 times. In 2022, in a single year, we record 15 extremely hot days in a year. This is unbelievable. Okay, it's so hot nowadays in Hong Kong in the summer. Okay. And for the climate projection for Hong Kong, Hong Kong Observatory has been doing that since AR4 or AR3. Anyway, now we are working on the AR6 one. Basically, we are using the Senior 6 models, and we have two approaches. The first one using statistical downscaling, this is a more conventional approach, and we are also working on a dynamical downscaling for the rainfall and humidity, etc., sunshine, etc. But for temperatures, I think statistical downscaling is quite good. And this is the basic trend that we can find nowadays from the IPCC models. Of course, we're going to see increasing mean temperature and mean annual rainfall, and we're going to see more extreme temperature and rainfall events. And importantly, that this mean sea level will continue to rise. This is all the projections that so far we obtained for the long-term trend. If we're looking more specifically to the temperatures and extreme temperatures, you can see that for the temperatures, we try to make use of the 4.5, 8.5 scenarios. You can see the temperatures will increase, of course. And in this case, to give you two magic numbers, if we're going to the 4.5 to the end of century, you expect at least 2 degrees, okay? And for the 8.5, you should expect something around 3.6 in the medium term, okay? If the emission going higher, then maybe even higher than that, okay? 3.6 is not a small number, okay? Remember, 3.6, if we have 33 degrees, 3.6 degrees means 36.6 degrees, okay? Okay, and for the extreme high temperatures projections, we can also see the non-linear effect will go on. The increase in the very hot day, hot nights will increase up to nearly over, not nearly, over 100 in the later on in the 21st centuries. So imagine the whole summer you will experience the hot night. Okay, roughly, okay? Of course, some days we will have heavy rain, okay? Hot weather and heavy rain, okay? So put all together. That makes the future climate very difficult. Besides this kind of studies conducted by observatory, I would like to highlight that the observatory also have strong collaboration with the academia and the stakeholders, because this is important that we work together to find out the science from multidisciplines to work together to enhance our service. This is some example here, of course, not exhaustive. Over the years, we try to collaborate with them to study all about climate change and extreme heat research. This is just some example about extreme heat research. We also have the heavy rain, extreme weather, tropical cyclone, etc. I would like to show one example is that this is quite successful, is that in around 2013 to 14, we collaborate with the Chinese University of Hong Kong to develop the Hong Kong Heat Index. Actually, this is, in simple terms, a modified WBGT that modified to suit the climate of Hong Kong. With this finding, we established the Hong Kong Heat Index for monitoring the heat stress, not just based on temperatures, and also based on the heat index data and the hospitalization data. We also developed. You see the circles, the orange circle and the red circle. There are two criteria that may be useful to enhance our service. Remember this too, because later on, about the warning service of Hong Kong Observatory, we established a 2-tiers level system to help to advise the public about the hot weather in Hong Kong. This is the very quick summary, especially requested by Cian to do that. We introduced a very hot weather warning about over 20 years ago, year 2000. Actually, this is a quite looking forward warning because at the time, hot is not a very important factor in Hong Kong at the moment, at the time. But we introduced this warning together, some very cold weather warning as well. But for hot weather warning, we have this established in year 2000. That mainly used for alert the public to the risk of heat strokes, sunburn, and in the very hot weather. And also it will trigger the opening of the heat shelter so that the people, especially those underprivileged people, can go to heat shelter when we have the warning issued. And for drivers, if the very hot weather warning is enforced, they no need to stop their engines and parking on the street. That is also important. But nowadays, it's not so important because so many electric cars nowadays. Okay. But anyway, for the very hot weather warning and advisory, we can see that 2 levels. The orange is the hot weather. We try to start to advise the public about the hot weather, even though it does not reach the very hot level. Okay, it's a precursor. And for the hot weather warning, we have the basic very hot weather situations, and we also, based on our research findings, we also recently introduced 2 more alerts. The first one is the prolonged heat, that is deal with the continuous period of high temperatures. And another one is about extremely hot. This is deal with the very high temperature event, for example, 35 degrees. This is the peak and the length advisory, so that we can have the possibility to alert the public about different kind of very hot weather. And more importantly, that we have used our website and the very famous mobile app to advise the public about warning and advisory, and they can also receive the push notification so that they know that the weather is hot today and you have to prepare. Okay, I see the 1 minute. Okay, luckily this is the last line. Besides all of that, public education and stakeholder engagement about climate change and extreme heat is important. So we make use of different channels to promote our services and promote the public awareness about climate change and extreme heat, all the way from radio, social media, and movies, television shows, and YouTube videos, etc. And hope that this can help the public understand the problem and how to respond to the extreme heat situation. That's it. Thank you.
Thank you, TC. So, we're going to discuss a bit more on the projections, especially Professor Im is an expert in climate modeling. So let's be educated how the models behave and what they are telling us. Thank you, Professor Im.
Yeah. So good afternoon. I'm Winston from the Hong Kong University of Science and Technology. It's a great honor to be here. And today I briefly review how hot the last year was and what are the really main factors that affect such an exceptional warmth. And I also try to touch what is the possible future condition that might happen before us. As a first figure, I prepared this one. This one is the temporal evolution of globally averaged temperature anomaly. And this year is the 2023, last year. So it's very clear. Last year is the warmest year since 1850. And more importantly, this is the first year that has exceeded 1.5 degree warming. That is, this threshold of 1.5 degree warming has a symbolic meaning because the Paris Agreement aims to limit the global warming trend no more than 1.5 degree warming, but you already will surpass. And to understand more details, let's break down this yearly value to the 12 individual monthly value. Then it's more obvious last year is how much warmer than is normal years. So this is different color indicate different timing, and it's very obvious is record-breaking monthly temperature anomaly appeared from the June, and it maintained the year-round, remaining year-round. And if we examine the data at the daily time scale, then actually 2 days in November has exceeded is 2-degree warming. 2-degree warming is really critical threshold set by the Paris Agreement to avoid a very dangerous situation of the climate change. So it's not really maintained, but temporarily we already surpassed such a critical number. So why did it happen? So I believe many of you may have heard that El Nino is largely responsible for such exceptional warming. I would say it's partially true, but only partially. El Nino is not new phenomena. El Nino and La Nina always exist, and they are kind of natural variability. So this one is a temporal evolution of temperature anomaly, and I also add some color to distinguish El Nino year and La Nina year difference. So here is red color indicates the El Nino period, while blue color indicates the La Nina period. So for the El Nino period, for example, in recent year is El Nino period, it seems the temperature is higher than the temperature at transitional neutral period or La Nina period. But El Nino impact is temporary. It does not change or reverse such a long-term trend. So we have to remember some La Nina years, some temperature here is recent La Nina years temperature is much higher than El Nino years temperature 1980s. So we cannot really blame recent warming only based on the El Nino. And particularly last year is what really happened. So the one study tried to quantify the relative contribution of different factors to exceptional 2023 warmth. So short-term variability, solar cycle, and volcanic eruption, and aerosol reduction all made some contributions. But their relative contribution is much, much lower than such the long-term steady warming. So it's very obvious. El Nino is partially effect, I agree. But the more dominant impacts come from such a long-term trend. And I also would like to emphasize the greenhouse gas emission. This is greenhouse gas, the CO2, the emissions, some temporal evolution. So greenhouse gas emissions, which are underlying cause of global warming, reaches the record high actually last year. So I'm a little bit concerned that we are trying to avoid acknowledging actual factor and instead try to find anything else to blame such a situation. So we have to keep in mind that this the emission pathway is really matching with such the warming trend. So we are eager to know what really happened in this year. So unfortunately, so temperature anomaly observed up to now is not really desirable. But at the same time, we don't know such a grim situation persistent throughout whole years. We don't know. So, but some estimate, I would like to share some available projection for this year's temperature. So the all estimation, this is projection, all estimate from different groups show is slightly warmer than last year. But openly, I also want to share some figure, last year projection. So all groups actually eventually fail to project because this is last year projection, so the all failed. But we have to acknowledge climate projection is quite different from the weather forecast. It's not really possible to provide very accurate information 1 year ahead in terms of the exact timing and exact locations. So So rather than we really obsess individual years fluctuation, I would like to emphasize we have to more careful such a long-term trend. So even though this year is slightly lower, but another summer is waiting next year and another years. So the long-term trend is the most important. Most important. So you may wonder, even though we cannot really provide accurate projection 1 year ahead, but how we can believe climate condition at the end of 21st century? We can. We have a very nice scientific tool, so-called climate model. Climate model is simply, I can explain, a digital twin of our Earth climate system. Climate model is trying to mimic our real climate system that include extraordinarily complex and non-linear processes. So simply we chop up our Earth, a very small piece, and incorporate mathematical formulas to describe nature's behavior, how to change the temperature along the season, how to blow wind and day and night. And then with the supercomputer help, we can make numerous solutions. And then I know that some of you are very skeptical for the reliability of climate model. But believe me, the climate model's skill is already good enough to fully understand the impact of anthropogenic contribution and and quantify anthropogenic impact. So for example, in this figure is black line is observation. And if we do not consider any anthropogenic forcing, then all models completely fail to such a upward trend. But if we include in greenhouse gas impact, then almost all models shows such a upward trend. So the climate model is useful. But still, I'm not saying climate model is perfect. The climate model sometimes wrong, but still skillful. And we need to find the uncertainty from the other source. So for example, this is uncertainty rate, is fraction. So when we produce the future climate information, we may consider these three main uncertainty sources. So at the end of 21st century, most of uncertainty from the emission pathway is not climate model. Climate model provide already reliable information. So it's in some sense, this is a good news because we can reshape temperature trend if we change, if we select is right selection. If we make some right selection and we make some some pathway, then we can change it, reshape some temperature trend. So I would like to emphasize future temperature information is not perfect, but their uncertainty mostly come from the emission scenarios. And HKUST team, now we are really working hard on produce more reliable climate information than is normally available data set. For example, as a second talk addressed, Hong Kong is particularly experiences rapid urbanization. So we try to incorporate such an impact into the climate model. Then we can produce more customized and more reliable climate information. And as a representative result, I would like to introduce only this result. So during the heat wave, duration of heat wave and heat wave intensity is expected to increase very significantly, even under the intermediate greenhouse gas emissions, let alone in high emission scenarios. So I would like to conclude my talk saying that it's time to embrace scientific evidence and to prepare a better future for us as well as the future generation. Thank you very much.
Thank you, Professor Yim. So seems to me all the presentations are really sobering, and also as pointed out by the speakers, actually the past 12-month running average global air temperature has already exceeded 1.5 degrees. So even though the scientific community hasn't yet been able to confirm this to be breaching the Paris Agreement, but we are getting close. And really, really hot situation are already affecting Southeast Asia, as we watch from the news. So my concern is, first of all, how are we going to survive this summer? TC, what's the official forecast outlook for this summer?
It's always my pleasure to answer the questions from our director, former director. Actually, not for this year first. Last year, we already had the hottest summer. So based on Professor Im's findings, I think it's going to be another hot summer. But really able to reach a new record. I do not expect it will be cool, but it will definitely be hot. But whether it will be able to break a new record, it will depend on many situations. Depends on the El Nino, La Nina, the tropical cyclone, the heavy rain. So hard to say, but we expect this year the annual temperatures in Hong Kong is going to be much well above normal, and with good chance reaching the top 10. This is our current forecast, but of course there's still quite a lot of uncertainty because towards the end of the year we expect that there are development of the La Nina. So we may expect tropical cyclones again in the late season. So there's uncertainty, but likely the temperatures this year will be above normal and have a good chance to reaching the top 10.
So very hot, and also some more typhoon expected in late season. There are also some saying that even though part of the heat is due to El Nino, and then it may be abated later on due to La Nina, but another saying is that maybe the successive El Nino actually has maintained the increasing trend of our global temperatures, and so it's not going to come down. What's the current understanding, for example, Sarah?
Yeah, that's a really good question. With El Nino, so that's certainly a reason, a small piece of the puzzle why temperatures were so hot last year. But also, it can also be more of a delayed effect too. So it can also lead into this year, that this year will be also quite hot because of El Nino. And what El Nino or La Nina, its sister, does is either amplifies or dampens what's happening in the climate trend because of climate change. It's not necessarily boosting or taking away, depending on what phase you're in. It's just because that's a naturally hotter phase. It's just slightly hotter than what you would have expected if it was a natural situation. So it's just temporarily doing something to that climate signal. It's not a long-term effect, if that makes sense. The long-term effect is the climate trend because of greenhouse gas emissions. So there'll always, I guess what I'm trying to say in a long-winded way, there will always be variability around that trend, in part due to El Nino and La Nina in that phase we're in.
Okay, so, yep. Professor Im?
So actually, now is El Nino is sharply decaying, and we move to the transition maybe several months, and then its phase will change to the La Nina. But that doesn't necessarily mean Hong Kong will be safe from the heat, because if there are some time lag, when something is happen, sometimes there are some time lag, and at this moment we cannot exactly project is several years or several months even ahead. So, but we have to keep in mind, even though this summer is safe, how about next summer? So his long-term trend is much more important rather than some short-term fluctuations.
Yep, Sarah?
Yeah, on top of that, what Winston showed about the different El Nino and La Nina cycles over time, today's La Ninas are warmer than the El Ninos even prior to the 1980s. So it just, and that's because of climate change. So that it's, things are warmer already. This summer might very well be in the top 10, but even in 10 years from now, in a La Nina summer, it could be hotter than what we're having now, very likely to be.
Right. So, as the former director, I'm most concerned about warning the public about all these ranging from daily forecast to climate outlook. So right now we notice that in different countries we use different parameters like WPGT or Hong Kong Heat Index or whatever you name it. And then we have also different system looking at different parameters in different cities as well. Why it's so hard for the community, meteorological community, to harmonize the systems or the metrics? Anyone like to give it a go first? Okay, you are well prepared.
Not well prepared, but as a Met Service in Hong Kong or Met Authority, I have to answer first. Yeah. Okay. Actually, I think each matrix or indicator that used by the Met Services has its own weaknesses or strengths. And it's hard to find a one-size-fits-all matrix or indicator that can universally be applied to all climate regimes and applications. So that's why the system used in Hong Kong will be very different from Australia and different from Korea. Korea also uses WGT. Yeah.
Singapore too.
Singapore too. Japan too. Yeah. But with different application approach or warning approach. So that's why that will evolve into a large varieties of index and Met Services warning approach. But the ultimate goal is to have the early warnings and advisory to the public. As long as that can trigger response, this is important. This is why WMO saying early warnings for all. Okay? And talk about WMO, and as far as I know, they are actually working on a handbook that to prepare to a handbook on the extreme heat index. I think they are working on that very hard, and I saw already comment on the recent draft already. So I think John L. is working on that. So I hope that they can provide the indexes altogether used by different Met Services and countries, and so that provides some guidelines for the other countries to select the appropriate index or approach to enhance their heat stress information services.
That's very good news. In fact, if you read the media, you can find out that even for the heat waves now going in Southeast Asia, people refer to different indices, different apparent temperatures, things like that. So it's really confusing, even to me. So Sarah, anything to share from Australian perspective?
I might just start off by saying I was actually really impressed to see the app you have here in Hong Kong and all the public messaging that goes out. I think we have a lot to learn from you guys. So we use a different metric to measure our heat waves. We do have an operational forecast, and that actually came about after another really bad heat wave 15 years ago, and the Bureau of Meteorology had been developing that. But the Bureau will issue a warning, and then it's up to other services to do what they want with that warning. So that might be, for example, in public health. What does that mean for them? That's not up to the Bureau of Meteorology to decide. They take heed to that warning as they see fit. They are getting better, and I think that WMO has got a lot of reason behind that in terms of giving out these forecasts. There's a lot of research going into how to communicate that better to the public, but I haven't yet seen any of the sort of messaging coming out that you have here in Hong Kong. We do that with bushfires because of the disasters we've had, but I think even culturally, yes, Australia is hot in most places, but culturally we see the heat a bit different. On top of that, in most places it's not quite as humid, at least not yet. So the metrics we use are based on maximum, so daytime and nighttime temperature. We haven't yet incorporated humidity into that heat wave definition. But given what I know, given what Winston was presenting, given what we've all now know here, we need to lift our game a bit in terms of communicating to the public what they need to do.
I see. So in other words, in Australia, there is only one system, and for the general public, and then the different communities, different sectors will make use of the same warning information for their own sectors.
That's correct.
For the vulnerable groups.
Yeah, that's right. So the Bureau of Meteorology releases an official forecast, and the heat waves categorised. I don't agree with what they call it as a low intensity heat wave, where it's still really hot anyway. and then a severe and an extreme, or so there's 3 categories. And then they broadcast that out, and TV networks might pick that up and put that on their broadcast, or the health services might work out what to do in terms of their resources, or sport might stop playing, or what have you. But it's up to them to make those decisions based on what the Bureau says. The Bureau doesn't tell them what to do, but it is one standard national definition. Sometimes some industries might say, oh, well, actually, we do need to incorporate humidity. So once the forecast is given, then they might use something like apparent temperature to say, well, we're not playing sport today, or once it hits this apparent temperature, then we'll see tennis or whatever it might be. But it's a lot more reliant on, the vast majority is very reliant on that one big forecast.
Good for thoughts for us. So maybe at this point, I'm sure the audience have many questions for us. So may I open the floor for you to ask questions for our panelists?
Hello, I'm from Oxfam, Hong Kong. Thank you very much for your sharing. And Oxfam concerned the poverty issues in Hong Kong, and also the poor people suffering from the climate change. And we always find way to help them to adapt to the climate change situation. And outdoor worker, for example, the cleaners, endures a significant challenge to the climate change, especially to the extreme heat. It is very commonplace in Hong Kong. So we are very happy to know that the heat index provides very good information. Reliance on a specific locations. Just mentioned, this is from the Kings Park monitoring station. But we observe that workers working in other different districts may experience much higher temperature before release for the alert from the government. So they are not allowed to have their rest, so that they have to work still under very hot temperature. So I would like to ask for your advice or comments, any suggestion on how to address this issue. Thank you very much.
Yeah, thank you. Regional differences. You like to take it first?
I see you looking at me, so of course. What should I say? Yes, now I think the neighbors department are using the data in Kings Park to do that. We have great discussions actually on this weather regional, etc., because we have very significant regional difference in temperatures in Hong Kong. So that's why the first thing first, the Hong Kong Observatory has opened all the data online, so the public can easily access this. And for the
OHL has also got Beast River, right? WPGT,
yeah.
Hong Kong Heat
Hong Kong
Index,
yeah.
data openly available.
So we have actually data, not just temperatures, you mean HHI, humidity, wind speed, everything online. So they can access this. And also, when formulating the Labour Department's heat warning for workers, I think we also provide all the historical data, and as well as our meteorological expertise for them to formulate their warning services, so that we have provide all the support for them, so that they can do it operationally, professionally, and engaging their professional bodies to set up that. I cannot say whether it is good or not because it's not under our department. But anyway, I think we should see it as an important step of government to help to alleviate the heat risk in Hong Kong, not just for the general public, but for specific community. And of course, there are always room for improvement and always room for refinement based on the feedback from the community. I think the government, I cannot represent the government, but in general, the government will definitely including observatory, labor department, and all the government departments are actually willing to listen to public's feedback and try to, within their capability and scope, and balancing all the people's interests to refine and improve the service. Ultimate goal is to help to serve the public. Okay, thank you.
Thank you, TC. So actually, I'm not a panelist, but I want to supplement. Winston, you at the back, our IPCC Working Group 2 co-chair will be on our second panel. But actually, I really impressed when I was visiting Singapore last month, and they are providing WBGT heat index information around the country for use for the purpose. So maybe we could also consider providing more information available to the public and to the labor sectors. And I truly believe that our observatory will work closely with all the stakeholders to take forward anything of benefits to the society. Oh, other questions?
Hi, and thank you for your wonderful presentations. I'm from Hong Kong UST. My question is for professor in the Hong Kong Observatory. I'm very curious about your cooperation with other stakeholders like government bureaus, different government bureaus, because I think living in Hong Kong, I feel like when we see there's extreme weather event, and we always see many public information everywhere in highway transportation and everywhere. I feel like this cooperation is really good, and I wonder how you manage this cooperation and what challenges right now you have. Thank you.
Thank you for questions, and I'm happy that the observatory becomes so popular. Yes, stakeholder engagement, not just for government departments, and really sometimes can be difficult because we have the secretary here also. He's looking at me. Actually, I think we observatory actually over the years is making significant effort to engaging different stakeholders and government departments, not just to improve our service, it's also trying to help them to utilize the meteorological data, information, and warning services provided by the observatory to improve their services. Besides the government departments, of course, we are working closely. We also work with the universities to set up the scientific research, to have the scientific findings to underpin all the enhancement of services. This is one example. The second example is we work with the senior citizen health SCHSA.
Yeah.
Senior Citizens 養者安居協會. Okay, I forgot the full name. We work close with them for both hot and cold weathers, so that they can help to propagate, promote all the knowledge and awareness to the senior citizens. Okay, and as well as for government departments, we have, of course, Labor Department, Department of Health, Education Bureau. We are more than willing to work with them, and also working very well with them to provide our knowledge, data, so that they can formulate their services guidelines as appropriate. Okay. One example is that not just for heat. Before the typhoon season and heavy rain seasons, we have the meetings with all the government departments to formulate to review last year's give and take, and then try to improve our service and prepare for the coming spring season. This is something that at least we will do every year. Okay.
Thank you. I'm aware of time, and also our next panel is, I think, really energized to move forward. But I see a high hand, Edwin. Yeah, please go ahead with your question.
Just, I would like to know: is it even better if to protect the public health and the workers' health during the very hot weather, that not just the Labor Department to send out that warning, but it's a special committee. Is it possible that the Hong Kong Observatory, Labor Departments, and Department of Health, because medical profession need to go in to consider the health aspect of the workers, 3 parties together to form a special, working group for this special hot days to join the issue, the warning to the public to ensure that health of public is being protected. Thank you.
Thank you. I take this as a suggestion, and maybe it's beyond TC's capability to answer this.
Yeah, certainly, given my ranking here, as totally beyond I'm on bottom of that. Anyway, but this is a really good suggestion. But just one clarification is that the warning issued by the Labor Department actually now is disseminating through the Hong Kong Observatory app and website because our popularities. Okay, many people installed our app so that it's very efficient. They can get the push-up message. That's one of the collaboration that you can see the government department now stay working on. Once we have a very good platform, the Observatory app, many services are actually looking upon us. They want to use our app to disseminate the important information if it's related to weather, or maybe later, or not just for weather. But anyway, this is one of the, I think that we can see the collaboration between governments. And of course, what Edwin said is something that we can consider by the other departments. But this now actually beyond my position to answer now. Okay, thank you.
Thank you. So, one more.
Hi, thank you. My name is Chin, and I have a question for Professor Perkins-Kirkpatrick. I'm from a background of urban planning and then also a climate activist, I would say. My question is, in your study on the non-survivable days for 65 years and older, can you talk a bit more about how you've done that research? Was it through statistics, or was it modeling, or was there any involvement in finding information on the hospitality rate, etc.? And if so, are those data accessible in Australia publicly? Yeah,
So,
thank you.
Firstly, no, the data is not publicly accessible yet. I haven't actually published that study yet, but I know how interesting and how pertinent it is, especially to a hot and humid climate. So that's why I show those today. So the way that work's actually being done in collaboration with human physiologists, and they've actually come up with a way to define those, like that livability or survivability thresholds based on those 2 age groups. And it's not just what used to happen 15 years ago would be a bunch of climate scientists saying, that threshold sounds really unsurvivable, we'll just run with that. But they've actually come back and said, well, no, it's about how your body copes during that heat. So I'm sure, we all know and we've all really well experienced that once it gets hot, we sweat. That sweat evaporates, it cools us down by evaporative loss. If you're older, that becomes inhibited. If it's humid, that becomes inhibited. And what they have done is basically model that curve where that heat and humidity threshold is important. And that threshold is lower once you become older. It's probably also different for different genders as well, and even potentially different ethnic groups. We're not sure yet, but it will shift around different demographics. So once we had that physiological model, we could then fit that to climate model projections, which is what Winston explained through those digital twins. And so using future projections of temperature and humidity, we could then count, well, what days are basically not survivable. Now, under that, there are 4 other categories, which are called livability. I think that's the term that they were using. A category of 1 is fine. That means you can live without any physical impairment. But if you get up to a livability of 4, you can survive, but basically just by sitting still and not doing anything at all. So that's also the next frontier. I know there's people working on this now. Well, how does that change? How do those categories change across the world? We are also doing similar projections for Australia, and we do hope to zoom into other parts of the world and look at different cities. And also those projections, I will say, was just from one climate model. It may not be the best one, we don't know yet, but it was just to demonstrate that firstly, survivability is challenged the higher we warm. And secondly, Unfortunately, for older generations, it's much worse. I didn't actually say that in my talk, but a lot of the world is going into an aging population, particularly by the end of this century, and that's another huge concern as well.
Yep. So, by the way, just a follow-up. You also have access to the mortality data in Australia to do this work.
Oh yes, gosh. So I'm not an epidemiologist. I'm a climate scientist, and I'm not even going to pretend to be part of that field. I have worked with epidemiologists before, and we can access that data to say, well, if there's a heat wave, how many extra people died, right. And physiologically, what was the effect? Not just how many deaths were great, how many more deaths were there relative to an expected threshold, but how many people died directly due to that physiological extreme heat response. We can do that. I understand that getting the data can be a bit of a challenge in Australia.
Exactly.
It's
Hong
there.
Kong also, yeah.
Yeah, but it's also, we also have different states and territories, and they have different laws about how you extract that data. You're relying a lot on the practitioners to record appropriately. And that's not to say doctors don't do their best. I'm sure they do. But if it's a very bad day with lots of presentations in hospital, it can be a bit more tricky. On top of that, if it's a really big heat wave and there are a lot of extra deaths, it's what we term the silent killer. It doesn't happen straight away, and you don't die immediately due to heat stroke. It exacerbates underlying conditions. Right. It can fry your kidneys. It can really affect your heart. And often people die 1 to 2 days later. So recording those deaths, sorry, I know this is really morbid, I'm really sorry, but often it's hidden in that data. And there was a study that came out not so long ago that estimated that the mortality rate due to extreme heat in Australia was underestimated 50-fold.
Wow.
Yep.
That's something really important for us to take a look.
Because it's not like, and again, this is morbid, but it's not like other extreme events where the effects are quite instantaneous. It takes time for the body to shut down because of that exposure to those really adverse conditions.
Thanks very much, and I believe we will continue the dialogue. But as I know, Sarah is heading towards the airport now, so we better have our coffee break. Thank you very much for your indulgence, and we'll continue at 3:45. Thank you very much.
Okay, I'm Alexis Lau with the Division of Environment at HKUST. Very happy to see so many people here. Today, we actually are restarting a series in the middle because we had 2 conferences, one in 2018 and another one in 2022. But we think that actually climate change is happening so fast and so many impacts coming in. We cannot afford to visit this once every 4 years. We really think that this is something we really have to routinely talk about. So instead of going for a big conference once every 4 years, we hope to actually focus on individual topics to do short but focused discussion. But it's also difficult because whenever we start talking about heat, we talk about, because of the heat, health, the heavy rain that comes with it, and it almost automatically link up with other things. But anyway, what we are planning to do is to start with this particular series. We will be talking about heat. We will be talking about heavy rain, maybe sea level rise, health issue, other things, probably in the frequency of one of this type of focus session, 2 a year. That's the idea we are planning. But this is certainly having other colleagues from around the world who are leaders, who are really doing a lot of work in this topic, coming to Hong Kong and share the experience is really important. And for this, really this time we are very fortunate to have great support from many countries and coming to share their experience here. Okay, So this time, we actually have a very packed panel. We have 6 panelists. And instead of asking them to sit, I would say that they better just sit here and also watch other presentation. And I would try to give more time for the question period later. Okay? So I would ask them to talk a little bit about what they have, and then probably go directly into the open question directly. And we will maybe summarize it at the end with a few questions. Okay. So without further ado, I think let's start this session. And we are really very privileged and very thankful for Winston to come not that far away, but he is a very busy person. He is the co-chair of the IPCC, the new report, AR7. Yeah, the co-chair of the working group 2, which is the most, from my point of view, actually become the most important part of adaptation and how to reduce the risk and so on. He's also a professor in Singapore, SMU, Management University. Sorry. Yeah. So thanks so much. Floor is yours.
Thank you. Thanks, Alexis. Funnily enough, I was here 6 years ago for CARE 2018, where I came in talking about coastal city floods after Typhoon Mongkut happened. So 6 years later, after a very strong, still ongoing heat wave, I get to visit Hong Kong again to talk about the work that I do in extreme heat on top of the IPCC adaptation and risk reduction work. I just fear that with climate change ongoing and what was presented in the first panel, I might have to return to Hong Kong again if CARE repeats itself. You know, there seems to be a pattern there. But that said, once again, I am going to tell a story, a very short story, because we've got a very good panel here. I'm very interested to hear what they have to say as well. The story is about 2 things going on at the same time: climate change and urban change. I'm going to talk about the risks that develop from this interaction between 2 systems, particularly those risks that affect human health, as well as for infrastructure, the key sorts of operations that both governments and private sectors they are engaged with in cities that will be directly affected by climate change. In this case, what we call urban overheating, the combination of the heat island and extreme heat. And then lastly, I'll pivot and talk about what some places have done to reduce the risk, what some places have done to increase the adaptive capacity and the adaptation process to overheating. I'll talk a little bit about the work that I'm doing as a professor of urban climate in Singapore, and also point out how the academic work that we've done from my colleagues at SMU and other academic institutes in Singapore. We've worked together with the government, we've worked together with the private sector to have a unified, integrated approach to reduce risk. So hopefully there can be some takeaways from this audience to pick up on. To start off, just the story of the urban system on the right, climate system on the left. The figure on the left is something the first panel talked about in terms of very notable, significant changes in global temperatures from climate change, combination of greenhouse gas emissions and deforestation. Everything there looks red, which shows a significant increase that is from the human influence on emissions and deforestation. On the right is a figure about urbanization. It is also increasing worldwide. In 2007, when the first iPhone was released, it was also an important threshold because more than 50% of the world's population now live in settlements in 2007. This is a projection from the United Nations to 2050. The colors are of interest because anything in yellow or in purple indicates countries that have cities with more than 50% of their national population living in there. So lots of future urban growth will take place in East Asia, South Asia, parts of Sub-Saharan Africa, and already your mature countries in North America. In Western Europe, they're already well in the urban phase. So you're going to have a lot of capital there, not just knowledge capital, human capital, but also financial capital. That's where the next point happens, where you have a lot of risks that combine together because you put urban systems in a climate system that is changing. In the conference that Alexis was talking about, we focused a lot on extreme heat. We talked about urban heat island issues. You know that cities, because of your concrete, your asphalt, your air conditioning, your traffic conditions, all the extra heat goes into the urban environment. And this is on top of the sort of global climate change that's happening, 1.4, 1.5 degrees C above pre-industrial eras, as what the previous panel has said. This showcases, or this figure from the last IPCC report, we developed this to highlight the key cities, the biggest cities around the world, overlaid on top of weather conditions or climate conditions, where you combine temperature and humidity. And to answer the question that the lady asked previously, this study also links these temperature and humidity conditions to recorded observations of heat stress or heat stroke deaths. So this highlighted area here shows you the days in which air temperature and humidity combine, where under historical conditions, people have died. And this is the present day, already parts of Southeast Asia where I'm from, parts of East Asia where we are currently at right now. There are already conditions where about less than 100 days a year, you already experience these conditions where people will die without adaptation. A 2 degree C world in the middle of this century, this is a conservative estimate, which we based, the studies that this figure was based on projects. Again, you can see the darker colors now in the tropical zone, primarily where I'm from in Southeast Asia. We are going to expect almost year-round conditions, where if there's no adaptation put into place, if there's no way to reduce risk, more people will die from extreme heat and humidity conditions. In fact, the news reports that I pointed out here, reported from the SCMP and from Reuters, just last week, you already see 40 people died in Thailand, schools have to be shut down, the Philippines are already, in the Philippines, schools have to be closed because of these extreme heat conditions that regrettably will be more frequent and more intense in the years to come. The other thing to point out is that these urban overheating risks, they do not stay within their own lane. What we found over the past 5-6 years when we did the climate assessment for the IPCC report is that we've seen emergence of compound and cascading risks that what happen when you combine what goes on with the climate system with cities. Using an example from, not from heat, but this also applies to heat. Let's say there's an extreme flood or storm surge that happens from a typhoon. It hits the energy supply of a city. It doesn't just stop there. It propagates to the transportation system. It propagates to your IT system, all your internet, all your phone systems get hit. It propagates to urban services, your medical facilities that can't operate at 100% efficiency or capacity because that storm event or the heat event takes out a lot of your infrastructure. So the compounding effect happens, and then it affects what we call the social infrastructure, all the frameworks, all the social components that affect people who live, work, and play in cities. The concerning thing is that that might be just an acute event. What was presented in the first panel, we know that heat events, they're going to be a very common occurrence in the years to come. From an acute occurrence, it becomes chronic. And when it becomes chronic, you've got cascading impacts. Again, in this example, you look at how transport systems, IT systems, urban systems will continue to get affected. But for cases like green infrastructure, which we know are good nature-based solutions to reduce temperatures, their effectiveness can also be affected because these hazards become chronic in nature. And when it hits social infrastructure in the long run, what happens? If you are living in a city that is perpetually affected by typhoons, heat waves, flood events, would you like to stay in that city? The evidence is no, people will leave. If you are a multinational company dependent on a labor force, highly educated labor force, and your labor force doesn't want to stay in that city, what are you going to do? If you are a policymaker dependent on tax revenues from these high-earning individuals and they leave, what are you going to do about it? So this is how that climate system interacts with the urban system, and it has long-term consequences if you don't consider how to reduce that reduce the risk by adaptation. So that's the bad news. Can I pivot to the good news, at least from the work that I'm doing in Singapore? I'm a principal investigator in this project called Cooling Singapore. What we've done over the past 7 years is we've listed out a whole compendium of 86 strategies to reduce heat. It's come out in the news. This was in 2018. In recent years, we've been trying to develop a digital twin for policymakers to play around and to see what scenarios work in reducing heat exposure. The work that we've done has come out in various articles in Bloomberg, WEF, Straits Times, more recently in the New York Times as well. My lab, we've been trying to make sure that the digital twin, the models there make sense. We don't want the garbage in, garbage out effect that will affect the decision making of policymakers. We have a mobile cart that represents human and how the human is exposed to changes in temperature, solar radiation, wind speed, and humidity. And we've pushed it around, or we pulled it around parts of where my university campus is to measure what sort of changes in exposure will happen to the cart and or to the person as they walk around an urban environment. We found out that shade, for instance, through artificial means or through vegetation means, is a key factor in reducing heat exposure to this end. Finally, because I know I'm running out of time, I'm going to point out that in that sense, the research that I do is just one piece of the jigsaw puzzle to reduce climate impacts, to improve adaptation. So this is the Singapore Green Plan, which I'm going to point out 3 things. One is that it's a multi-ministry, multi-agency affair with the Singapore government. It's not just an issue for the Environment Ministry. It's an issue for the transport, education, energy, as well as the National Development Ministries. It has several pillars, one of which is on reducing climate hazards and increasing adaptation. Cooling Singapore is here. But of other things of note, the public sector, the government is taking the lead in this in terms of trying to reach net zero by 2025, putting in a carbon tax for industries that are highly pollutive, and the revenues from that tax are revenue neutral. They go into R&D for more efficient technologies, for instance. There's a push towards better education for a greener citizenry where NGOs and local activists are also part of this green plan. And more importantly for the economy, there's ways to upskill or reskill workers who are moving away from a dirty carbon-intensive industry towards a green industry. One example is, I point out, you can see there Singapore is going to replace its internal combustion engine cars, moving away from diesel and petrol towards electric vehicles. What's going to happen to car mechanics who are used to repairing diesel and petrol engines? They have to be reskilled to deal with battery technologies or other sorts of newer technologies that your Teslas and your BYDs have in mind. It's incorporated in there. There's support from the government and also encouragement from the private sector to get on board for this long-term plan. I think that's it. I exceeded my time, but thank you all for listening. Back to you, Alexis.
Well, thanks a lot. Okay, actually, I think because I went with CM to Singapore just last month, and we are really impressed on a number of things. In particular, actually, the design change in a lot of the new buildings, as well as the use of ventilation, mechanical fans. Because in Hong Kong, I think we are so used to air conditioning, we don't even think about it and think that is the solution. But going to Singapore, seeing that they really look at it, and from the city planning all the way to this new thinking, I think is good. But I think we have very tight schedule. So now I would like to invite Professor Peter Crank from University of Waterloo. Actually, there was some talk about health, and I think Professor Crank will actually talk about how, on the health side, how heat can affect and what you are suggesting us to do. Okay.
Thank you, Alexis. So this brief talk will be sort of exploring the mental health side of climate within our cities. And so getting a bit into the pieces of health, not just the physiological, but also our psychological health and well-being. This is sort of a framework to sort of explain the ways that we're seeing the combination of urbanization and urban heat and their impacts on both the physiological and the psychological health of our residents and communities. From lots of different research, we know that under extreme heat conditions and urban heat islands, that people have an increased risk for heat stress and heat stroke. We see that in a variety of different places. This is the primary thing we see in our heat warnings and heat advisories, is being concerned about that. We know that we have decreased thermal comfort. People don't enjoy being outside when it is extremely hot, and they're more uncomfortable. They begin to sweat. There are even some respiratory issues that begin to arise when we're dealing with these extreme conditions within the city. But there are also psychological impacts that we know through research of both urbanization as well as extreme heat. Those can include things like increased aggression or irritability. Increased depression has also been associated with urbanization and heat. And what I will focus on is the increase in schizophrenia associated with both the urbanization and extreme heat. So some of the work that I've done in this space has been focused in Phoenix, Arizona, which, unlike Hong Kong, is not very humid, but it is very hot. The summer months, we will often spend, maximum air temperatures will be above 40 degrees C for over 100 days throughout the summer. Overnight temperatures there, on average, in the summer, are 30 plus degrees C. So it doesn't cool down at night. So even though there isn't a lot of humidity, the temperature is still quite warm. And so what I looked at in this study was looking at hospitalization records in the Phoenix area and associating that with minimum air temperature each day, so our overnight temperatures. And what we found is that for all of the cases, the hospitalizations that we looked at from 2006 to 2014, is that there is an increased risk in hospitalization for schizophrenia specifically, both in the extremely cold conditions and the extremely warm conditions across all of our data. Those risks increase ever so slightly for males and for non-whites. Those are the two primary groups that we're seeing an increased risk for. But what I will note is that with both of these instances, that inflection point of beginning to increase pretty dramatically is around 30 degrees Celsius for our overnight temperatures. So that means that schizophrenia hospitalizations in Phoenix are rapidly rising throughout the entire summer months. And this is in the 2006 to 2014 period. The last panel told us that these temperatures are going to become our cool summers as we move into the later portions of the century. So this means that we are going to be seeing even higher risks, and those risks translate into monetary impacts on our healthcare system. So this is converting that hospitalization record data into healthcare costs, and I converted it into Hong Kong dollars as well, that over that 9-year period, it cost the Phoenix healthcare system over 200 million Hong Kong dollars to address schizophrenia hospitalizations that are directly attributed to temperature. Per year, that is over 20 million Hong Kong dollars, that if we address the temperature concerns around schizophrenia hospitalizations, we can reduce those costs, improve lives, potentially even saving lives along the way. And so one of the things that we propose as an intervention to address this issue, we know that green space within a city is incredibly helpful in order to cool a city. This is what was not mentioned in the Singapore Green Plan by Professor Winston Chow, is the nature contact and the increase in nature in Singapore. But we know that these urban green spaces originally, historically by designers, were proposed not just for their cooling benefits physically, but they were also proposed as an intervention to provide a space of mental calm or reduction in anxiety and peace in the midst of a bustling city. And there is scientific evidence that points to both the urbanization as well as extreme heat as factors in deteriorating a variety of mental health conditions, including schizophrenia, as I just mentioned. And so urban green spaces can provide us with an opportunity to both cool the environment as well as address some of these underlying mental health conditions. And so providing some synergy in that space so that as we cool, we are providing mental health benefits, and as we cool, we are also reducing that risk for hospitalization along the way. We can also think about all the other cascading impacts that urban green space can have in an urbanizing world of reducing or improving conditions around urban flooding as well as biodiversity. So getting to some of those other cascading issues that we see from extreme heat. So with that, I will end it here and take any questions you guys may have or in the following discussion. Thank you.
Okay, thank you very much, Peter. Actually, this goes into the discussion we have in terms of urban planning and also how to do cooling. And our next speaker, next panelist is actually from Venus, Enrica, sorry, my pronunciation is Cian. Oh, that's easy. Yes. Enrica actually will be talking about cooling solutions because I think, well, since heat is our primary concern at this point, and how do we actually do in terms of cooling solution, particularly on both temperature and humidity, I think is a very important thing. So, okay.
Thank you very much. And yes, I would like to take these 5 minutes to talk a bit more about one specific form and type of adaptation, which is that of air conditioning. Of course, air conditioning is very important. It has made life possible in certain places, but there are also, let's say, there is also a dark side associated with the air conditioning. And in my opinion, that has not received the attention that it deserves. So I just wanted to contribute to elevating a little bit our awareness about the possible dangerous consequences also of using air conditioning. And I will start, first of all, by talking a little bit also about the vulnerability and the sources of vulnerability. It was mentioned already in the previous presentations that it's true that, well, most of the people will be facing higher temperature, but there are also different sources of vulnerability, different groups of people across different countries. And in order for policy to be effective, we need to understand what are those different sources of vulnerability. So the starting point is essentially something that was already presented before. We know that the number of hot and humid days will be increasing. Here you see just different visualizations of days, number of days with a heat index above 32 degrees Celsius across different cities in the world. Main message is that we will have more of that from Asia to Europe. Of course, we have cities, especially in Southeast Asia, which are already accustomed to high temperature level. For Europe, you see that heat is really a new thing. And by the way, Europe is one of the regions in the planet which is warming at the fastest rate. What is also interesting is that, and what is also the risk that is emerging, is that these people here, now they're facing these unprecedented conditions in terms of temperature and humidity. And what are they doing? They adapt by using air conditioning, because that's the point. It's a type of adaptation that has established itself a little bit as the prevailing and apparently only cooling solutions. So the idea of this project that I've been coordinating for the past 6 years is a little bit also to question a little bit this paradigm. It's time to think about also alternatives to air conditioning. So more days with the high heat and humidity. As we said before, different sources of vulnerabilities. So, for example, in Europe, which is the place where I come from, the main group that will be facing these struggles in condition of high heat and humidity are the elderly. Europe is one of the regions in the world that is aging at the quickest pace. We have already about 10% of the population above 69, and it's a relatively high share compared to Southeast Asia, for example, where that share is about 5%. And this is going to increase. So we have these two co-occurring trends, aging and warming, which is posing challenges that policy should consider. In 2003, we had a big heat wave, during which the heat index was in the range of 32 degrees, the number that you saw in the previous slide. And during that heat wave, about 70,000 people died. And most of them were old people, most often isolated people. Since then, we have implemented adaptation heat plan and strategies. And indeed, I mean, heat waves have continued to occur even more frequently and extended. But for example, a new study of a more recent heat waves 2022 estimated a lower number of deaths, indicating that adaptation is playing a role. Another important source of vulnerability is marginalization. So in all big cities around the world, especially in the global south, informal settlements, marginalized group will remain will be highly exposed to the threat posed by heat and humidity. This is a picture that was taken in a favela in an informal settlement in Rio. So housing condition is also an issue, one of the dimensions that should be tackled by policy in order to make sure that everybody has access to thermal comfort. And lastly, was mentioned also by one of the questions before, outdoor workers. This is a source of vulnerability, I would say, across the planet, because they will be facing harsh conditions. And also here, we need dedicated policy. For example, in Italy last year, there was a law forbidding certain types of jobs under certain types of temperature and humidity conditions. Now, I come back to the issue of air conditioning, why air conditioning can be problematic. It's true that in certain conditions, that's probably the only cooling solution that you have, but in some other environment, I mean, in climates such as the ones we have in Europe, you could really manage heat and humidity with other cooling solutions. I call it like the blind spot of the energy transitions, because in our attempt to reduce emissions, we are not considering that air conditioning is, at the global scale, as big as India in terms of electricity consumption. And this is considering only home space cooling, so no business and commercial and public buildings. And I guess you can guess that if that energy comes from fossil fuels, then that means additional emissions being put in the atmosphere. And still, a big fraction of the population will actually not even have access to this type of cooling solutions. So what are the alternatives? In this project, actually, we were able to document some nice, I would say, best practices that are emerging in some places in the world. This is an architect in Indonesia who's trying to rediscover traditional knowledge and vernacular technologies and method of constructions to reduce the dependency on air conditioning in modern building. And there was another example in Tegal city in Indonesia where, for example, they're trying to build social housing, so affordable also for middle and low income groups, with natural ventilation, which do not need to rely on mechanical air conditioning. And with this, I stop the presentations. Here there is a quiz that you can take and share your cooling practices and more info on the scientific papers behind the presentation.
Well, thanks a lot, Enrica. Okay. We mentioned a little bit, I think Enrica mentioned a little bit on the outdoor work, the vulnerable marginalized group. Then I think this brings us to the next speaker, Albert from Thailand. And I guess because of time, I would let you just go into the details rather than going. Yeah, with the Stockholm Environmental Institute in Thailand.
Yeah, thanks a lot, Alexis. So when I flew to Hong Kong on Sunday, and the temperature around that time was around 40 degrees centigrade, 40, 41. So maybe the heat index would be around, I don't know, 45, 46, or something like that. So it was really hot. But yesterday, for the first time in like 2 months, there was rain. And also across Southeast Asia, they were already beginning to feel the rain. So if you like, the challenge that we're discussing now was resolved yesterday with the arrival of the first rain. But that's heating, right? In the next 3 months, perhaps, if there is a major typhoon again that comes, our conversation will be about typhoon. And then 3 months after that, we'll go back to heating. But as the science has demonstrated, all of this will be going up. So maybe our extreme now might not be not too extreme when we are in the future, in the next 2 years. And the same also with the typhoon. Maybe our typhoon that we will experience this year might not be the normal typhoon that we will experience in the next few years because the state of our climate systems. So that means we really have a lot of things to talk about. And I'm hoping, as Alexis already mentioned, I came from Bangkok. My organization is the Stockholm Environment Institute. We are a research to policy organization. So we're more on the action side, working with communities, working with policymakers on what are the things that we can do together. Again, as Alexis also mentioned earlier, the conference is called CARE, right? Climate Adaptation and Resilience, and it has happened already for several years. And I think that's what we need. We need an ethics of care, wherein C is not climate, but compassionate adaptation and resilience. Because as the questions already being asked earlier, there are certain groups of people who are much more vulnerable in our societies than other people, than the usual. So maybe those who are vulnerable to the impacts of climate change might not be us. We will feel some discomfort. But maybe certain groups are more worse off than we are. And we have to understand who they are. And Enrica already mentioned that who are they, and other speakers already have shown who are these groups: outside workers, women, elderly women, maybe children also. Maybe those who are working in occupations that they have no option, but they just have to go out and stay on the sun because that's all they can do. Otherwise, they won't get paid, right? So I think we have to really reverse the conversation because we know the science, we know who they are. We should talk to them about how they can actually effectively adapt and how we can build the resilience to climate impacts. Because otherwise, what might happen is that we think it is the solution, but might not be the solution, as what Enrica already mentioned, that our solutions might actually be creating other problems. So by having that conversations with these groups, with like what our colleague from Oxfam already asked, the poor people, for example, having that conversations with them, we know what might be the challenges that we are encountering with regards to heating, but maybe not only that, with other forms of issues that they will encounter. For example, maybe there are certain forms of domestic violence that they also have to contend with. So imagine, as already Peter mentioned, there are also psychological factors associated with urbanization. And if we only think of heating as one dimension, then maybe we are not actually responding to the challenge that these communities will face. And it is that, as again Winston mentioned, that there's this cascade of different impacts and they interact. And that interaction could actually, might best be the factors that will topple the household or the individual. So we need to understand that particular dimension. So as part of that compassionate adaptation and resilience, we have also to talk about funding for these groups, right? Because if you want them to adapt on their own, certain resources have to be available because adaptation and resilience cannot just be wished. We cannot just say, okay, you adapt, build your resilience. Opportunities have to be provided for these groups as well so that they can, on their own, on their communities, they can act together. And then the third one is that building on that idea that Enrica mentioned about maladaptation, the potential for our solutions to be maladaptive. Air conditioning, which demand a lot of electricities for their creating urban heat island effect, and then for their heating the urban environment. So what are those, as what Enrica mentioned, what are some of the solutions that actually prevent from, that will not lead to unintended consequences? Because otherwise, our conversation will just be progressing towards another problem, right? And our intention really here is to resolve the problem that we are facing. So, in other words, what we need is an adaptation that is really fit for purpose. And what do we mean by that? One, do we have enough social protection for these groups, right? Is our, as I think Alexis mentioned already, or as the previous panel already talked about this, the health services, do we have really a health services that can respond to the needs of those people who will be affected by extreme heating? How about our emergency services? And then there's also an important role being played by proper planning. So the green spaces, for example, we have to take that into consideration. Because at the end of the day, we're not just, I think our interest is not just urban heating, right? Our interest is the well-being of inhabitants, whether in the city and other parts of the country. So with that, the key message that I would like to bring in is that we have to be mindful also of other groups who might be vulnerable to heating, typhoon, and other challenges, and let's bring them into the conversation because maybe they themselves would have solutions that we have not thought about. Thank you.
Okay, thanks a lot. Actually, I think Albert has really right in terms of we have been doing science too much just by ourselves, looking at what we consider as the problem. And I think in the past few years, we start looking at, first from air pollution, but really talking to everyone about air pollution is not that useful. But talking to people who are more affected, like the Asthma Society or people, older people, we find that they are much more resonant. And without that talking, we don't know how to improve our support for them. And because of that, actually, we have been really, in the past few years, established relationship with some of the local groups that work a lot across the community. And in particular, Red Cross, I think, is one which we have been working very well with. And for the heat, I think ask them to share what Hong Kong has been doing in terms of helping the vulnerable groups, helping the more marginalized groups in terms of heat. But this, again, is something I think as academic we try to do more, going beyond just the science, but work more with the community. So for that, I'm inviting Eva to talk about Hong Kong's Red Cross, what they have been doing in terms of the heat.
Thank you, Alexis. And thank you very much for having me to share what the vulnerable groups in Hong Kong actually are facing under the threats of heat and extreme weather. And because today I only got a couple of minutes, so I'm focusing on people who are living in subdivided flats, which is a very special informal settlement that facing in Hong Kong. And I don't know if you have an idea that how many people are living in the subdivided units in Hong Kong. There are over 200,000 people right now are living in this environment. And what do Red Cross and humanitarian organization is doing for this population? So I'm going to show you. Apart from the academics and scientists doing all the research, the Red Cross, we also have our research on specifically on heat, and based on these findings, we identified different kinds of like toolkits or policies, and so for the national societies to adopt. But for that process, it is a long process. We need to understand the special needs of very special groups in our particular cities or countries, and then to tailor-made or contextualize all kinds of toolkits or measures to tackle their needs. And so I'm going to show you and go into a subdivided unit that Ms. Chan is living. She is living, as a single parent. Ms. Chan is living with her son, who is 6 years old. And when I go into her apartment, it's like this. You can see that. Look around, turn left is the toilet, and including with the kitchen. So it is very like typical case in the subdivided unit in Hong Kong that they are combining together the kitchen and the toilet. And then turning right is the little kid who is doing her homework, and then next to it is the bed. So this is all the space that they are living. And then you can also see that in the middle of the photo, you can also see that the wall, the color of the wall is gray. Why is that? Because the next door, the neighborhood next door, always, all day long, is turning on the aircon. And because of the electricity bill, Ms. Chan, they don't turn on the aircon so long for all the day. They will calculate the time every day, which timing they can afford for switching on with the aircon. Usually when they are asleep, and then they will turn on the aircon for a couple of hours. So that because of that very extreme differences in temperature, the wall inside her room, I would say, not the house, in her room, always wet and humid and then turning gray. And so as all the speakers have shared that under the heat, there are other consequences. And then there are potential risks that are facing by this particular population in Hong Kong. Heat, air pollution, and rainstorm because of the leakage, and the fire because of the always improper electric appliances and also improper electricity wires inside the apartments. There are a lot of fires happening in these subdivided units. And also poor hygiene and, of course, very stressful living in such very dense area. And we conducted, we tried to install like around 30, very small scale, around 30 sensors inside these apartments last year. And then we identified that over half of them are facing over 30 degrees Celsius indoor. And also, because I'm sorry for the very small English words. And also over half of them are facing excessive humidity. All of them without enough lighting. And around half of them, they have excessive CO2, and some of them, they have excessive PM 2.5 and PM 10. So all of them, they are in the risk of heat stroke or fatigue, allergy, headache, and mental stress. So this is the environment that these over 200,000 people they are facing. And for us, we have implemented a climate smart community resilience program last year to these households for over 700 households last year. And we replaced them with some better electric appliances because I would say, for example, some of the households, they use the refrigerator for over 20 years, and it's always overheat. And it produces more like hotter environment inside that apartment. That is quite terrible. And so we do the assessment and we understand their needs, and also we place them with the right appliances, and also more fans, small fans, and placing in the right locations. And very importantly, to give them more awareness, workshops or programming that I will show you to increase the awareness of what is actually happening of their livelihood or their habits in their daily lives. What is the relationship between their habits and also the environment. And very importantly for our approach, the first very important thing is to get the community engaged, to get the community participate. That is something that I think very special for the Red Cross to do in the community, is to link the people together. We hear their voices. We organize focus groups with children, with women, with the men who need to work all day long. And so we hear different voices to understand what is their livelihood pattern. And by understanding their pattern, and then we will find out the solution together with them. And right. And so this is the, and then we will decide what kind of materials we will give to individual houses, and also what kind of activities that they are interested. You can see that quite a lot, some of the activities we organize are outdoors, because they have very little opportunities to go out of their houses because of sometimes because of the they need to work very long hours for the livelihood, and also because of the they don't want to pay for the transportation to go out. And so we organize more outdoor activities for them and connect them with the environment, with the natural environment. They enjoy that quite a lot, and they enjoy the picnics and to the farm, something like that. And the one point very important is to engage the community. The second and very last important point I want to share is to connecting with the different partners in the society. So we connect with different groups who offer different kinds of services by their professionals, like repair of the electricity appliances. Some company they produce a sensor with a very low price, and then we also coordinate with other groups who offer the plants, and then so to give out to these households, and then put the plants inside there to improve their environment. So last but not least, I would say that the climate change is having the greatest impact on most vulnerable people, like, for example, who are living in these subdivided units. But believe that every one of us, we have our concrete role and concrete action that we can do, and that can make changes in building a resilient community. So thank you very much.
Okay. Well, really, I think we should thank Red Cross and many other community groups doing all these things. But I think the last few talk may be making people a little bit depressed, knowing so many impacts. But I certainly do not want that as the ending of this discussion. So what we have done is ask one of our colleagues who is helpful for bringing a lot of this international speaker here to actually look at what other places have done in terms of climate action plan, focusing on heat. So I think we are very adaptive, we are very ingenious, and by sharing, looking at what others have done, we can think about what maybe Hong Kong can do in one place, one thing or another. So Laurence, first, thank you for bringing a lot of the people here with Winston, but what other place has been doing?
Thank you very much, Alexis. All right, so my name is Laurence, and I'm from the Division of Environment and Sustainability at HQST. So I have a small research group that looks at climate, energy, and society. And some of the messages that Eva had delivered earlier is actually part of a master's thesis that my very good and excellent student, Miss Chloe Cian, has been looking at for the past 2 years. And for the last 8 months, since September, we have broadened out or focused specifically on heat. So that's why actually my friends are here. Yeah, so we are not necessarily focused on Hong Kong for our heat work. So I have a student who looks at heat vulnerability and strategies, coping strategies of elderly populations in rural and urban China. There's another student who looks at Southeast Asia, focusing on Bangkok and Manila. Another student looks at the role of AI and other emerging technologies and how to survive with heat. And another student is actually looking at adaptation finance. I think Albert had mentioned about the need to fund and locate resources and provide resources for adaptation, etc. But my task this afternoon is to look at how other cities and how other parts of the world are actually coping with stress, with the heat stress. So what I am being presenting is just a sample of a sample. So do not expect a lot. A number of sample solutions have already been floated around since the first panel, and of course this panel. But I really would like to use this particular framework to talk about what we should be doing in terms of surviving the heat. So this is coming from the Global Heat Health Information Network, which HKO is actually a founding member, right? So they have 5 pillars of integrated heat health action. Partnerships and capacity building is important. Heat vulnerability and impact science is important. Heat forecasting and services is crucial. Communications and outreach and interventions. So their framework is basically to reduce the impacts of heat on health. And it needs engagement with the people with the right knowledge and taking effective action. So there are various ways on how to do these pillars or to meet the objectives of these solutions. All right? But very crucial is to map where the vulnerable communities are. Yeah. So Chloe's work is actually on identifying where the energy insecure individuals are living in Hong Kong. Yeah. And it took her about 2 years to pinpoint where the energy insecure actually are living in Hong Kong. But the New York City had developed a tool called the New York City Heat Vulnerability Index. It basically maps areas most at risk for heat-related health impacts. So measuring urban heat is very important so that we can assess and direct or focus our attention on where to provide the most solutions. Melbourne already has a tool called the UHI Effect Mitigation Decision Support Tool, which allowed their urban planners to assess the potential impacts of different heat mitigation strategies across populations. This is an example in Toronto in Canada, where Peter is from. So they have a heat mapping to identify areas most vulnerable to extreme heat and has used this information to develop a heat relief network. So for Hong Kong, it's really crucial to have that map. So spatial scientists and geographers have an essential role to play to identify the most vulnerable places in Hong Kong. Ahmedabad in India also has a heat action plan, which is based also on mapping work. Second is heat wave emergency management. If you can still recall from panel 1, HKO has probably one of the world's most efficient and very user-friendly app on emergency management. In Melbourne, Australia, they also have a heat wave plan, which incorporates a heat health alert system. We have that in Hong Kong already. Paris already also has a heat wave emergency response plan. Basically, that includes the activation of cooling centers, increased public communication of risks related to heat, and to outreach to vulnerable populations. Yeah, finally, heat mitigation solutions. Yeah, so when we talk about heat mitigation solutions, it's not only the infrastructures. It's not only about making sure that we have ACs, we have these big fans, we have these cooling centers. So that's our hard adaptation infrastructures. But we have also to think about soft infrastructures. And this is about changing behaviors, mindsets, social structures, policies, regulations, etc. So in New South Wales, a state in Australia, they developed beat the heat web pages for public information. LA in the US has a plan, the Sustainable City Plan, which includes measures to reduce the UHI effect and increase the availability of green spaces. Earlier, Peter had mentioned about the need for urban greening. LA has a plan to plant about 90,000 trees by 2021. I reckon Singapore also has, I think, a million, not a billion, a million. Yeah, planting 1 million trees. This is from Paris, France. They developed a strategy called the Paris Climate Plan, which includes measures to reduce emissions and increase the resilience of the city to climate change. So the plan includes measures to reduce UHI and again, increase the availability of green spaces. So green spaces is really crucial and really important. But of course, you have to contextualize, right? In Hong Kong, we don't have, we have plenty of space for outdoor and recreation, right? But the built-up spaces is limited to 20-24%. But within the 20-24%, how much can we turn it into green, right? This is a crucial case study or an example from Slovakia because they focused mostly on vulnerable populations. Earlier on, there was a talk about already, some speakers have enumerated who the most vulnerable populations are to extreme heat. So older people, children, those living on top floors in poorly insulated buildings. We have talked about SDUs earlier. And those relying on facilities such as nurseries, schools, or care homes are the most vulnerable to heat stress. So the adaptation strategies, again, this should combine both hard and soft infrastructure. Greening urban areas, early warning, cooling of indoor public spaces, but most important is to inform and to provide more educational activities, especially on safe behaviors during extreme heat events. Going back again to the Global Heat Health Information Network, I reckon this is a very important, still emerging, although they have been there for the past 5 years or more. But they have a compendium of projects and studies, heat action plans, and case studies related to surviving the heat. So I encourage everyone to take a look at what they have already have compiled, and maybe Hong Kong and other cities in Southeast Asia and East Asia can learn from it. I think that's it. Thank you.
Now I think I want to invite the panelists to come out, and then instead of me asking questions, I think it's much better for people here if you have questions. I have less to do, right? Okay, any question?
Thank you all for all the speakers. Very good presentation. I have two questions for Professor Winston. So when we talk about urban change, the first question is, if we think about a question from the adaptation point of view, is it good to design a more advanced city to cope with the extreme heat, or decentralize some facilities to some rural regions? So which one is better for the extreme heat adaptation? This is the first question.
You want to ask the second question as well? Or?
Yeah, why?
Okay, for the second question, when we're talking about urban city, urban design, at least those regions, they have urbans. So in this world, there are still some more vulnerable regions. No matter they have a so-called urban or not, their entire regions are very, very vulnerable to the extreme heat. So any coping strategies for this kind of very, very vulnerable region?
Okay,
Thank you, Professor.
Tough questions, but very, very important ones. So the first question looks into whether or not you can apply an advanced city. I would be hesitant because how you define advanced, oftentimes people think of it in terms of more technology or more sorts of engineering solutions or infrastructural solutions to reduce risk and improve adaptation. I would disagree with that. In the last IPCC report, we made a very strong case in the urban chapters to point out that if you were to look into adaptation approaches, and these are not new solutions, these are well known, green infrastructure, good urban design, air conditioning, but with more efficient ways of doing so. You can group them into what we call physical infrastructure, nature-based solutions, talking about the importance of green spaces, like what Peter has mentioned, that has multiple co-benefits apart from reducing temperatures, but also planning and social policies. So the lowest hanging fruit that what we found is that if you want to really make a big difference, regardless of whether you're in a city or in a peri-urban area or in a rural area, is sometimes as simple as getting different agencies, different communities to talk to each other. What we found out in the Singapore case and in several other cities in Southeast Asia is that if you are inclusive, and this speaks to what Albert has said, if you're inclusive in bringing in different communities and stakeholders, bring them to the table, say this is what is at risk here. From governments to communities to NGOs to the private sector. if they say, all right, this option seems to work for the majority of us, and we can have plans to, let's say in the Singapore case, protect our heritage areas, to have early warning systems, which HVO has a fantastic early warning system in place. What do we do with that information across all different stakeholders? That to me is a advanced city in the case of reducing any sort of climate risk, be it from urban overheating, from extreme heat to floods and typhoons and everything else. So hopefully that answers your first question. Don't be fixated on technology. Second question is that on looking into areas that are not cities. You're right, there are very much more vulnerable places in non-urban areas, in rural areas. Wildfires can start in forested areas. In Singapore, we import 95% of our food from elsewhere. We are at great risk. Same for other places as well. We are at great risk when our food supply is threatened. There are other ways of adapting to the sort of extreme temperatures that will affect us, be it whether irrespective of whether we're in a city like Hong Kong or Singapore, or in a farmland community elsewhere in rural Vietnam or in the Philippines. Those options, I am the first to admit I'm not an expert in that. My colleagues in the IPCC have done great work in terms of looking at agriculture ways of adapting, new technologies, new crops, new farming methods that can adapt to the changing temperature and water resources that are available. So I would invite you to look into those sort of information rather than me speaking something which I don't really have total expertise about. Thank you.
Okay, maybe I will take another question.
It's again for Professor Chow. You mentioned nature-based solution. The unfortunate thing is that people in power in Hong Kong, they think nature-based solution is just a cliche, a jargon from the environmentalists. So how is it possible, or has it happened, that nature-based solution is mainstreamed into the thoughts of your government and other governments?
Good question. I would say that some governments, not just Hong Kong, they are also uncomfortable with the idea of nature-based solutions. In the IPCC process, I've heard cases where a better term is ecosystem-based adaptation or something along those lines. But it's the same sort of point. The fact that if you bring in the natural environment into the urban arena or into any other arena, it can help you with reducing risk. One thing that we've done, at least in the Singapore case, we tried to showcase a lot of evidence, not just on the cooling potential, but also other ecosystem services that park spaces. I'm using an example of large park spaces in Singapore. One place that I've done a lot of work in is at Bishan Ang Mo Kio Park. It's about the size of 62 football fields. It's being used by more than 250,000 people in residential spaces around that area. If you look into the temperatures that we've measured and modeled there, on average 1 degree, 1.5 degrees C cooler, very good. It also reduces flood risk. Around the neighborhood, there are some places where flash floods happen, but because the park space has natural ground to allow for water to naturally infiltrate, there's almost zero reported floods reported there since the park was in place more than 13 years ago. But the other thing of note is that that park space, and this speaks to, I would say, both Hong Kong and Singapore, private, public apartment blocks there, the condominiums and the housing. One of my colleagues in the National University of Singapore, they've done work there showing that the economic value of those properties increase because those green infrastructure are there. If you are a property agent, you can say, look, you are right next to a park space where everybody, be young or old, you enjoy there, you can increase the value of your property accordingly. And that data is significant enough. So one way is to pivot and talk beyond the science and saying that there is financial benefits in that case, in this case explicitly in properties value that goes up.
Okay, any more questions?
Hi, I'm from SEMP. So for the panelists, while green space is an effective solution to cope with extreme heat, but urban areas in Hong Kong are very dense and crowded, how can Hong Kong apply the green space solution? And for Professor Chow, As the urban area in Singapore and Hong Kong are quite similar, do you have any other suggestion for Hong Kong to adapt to and tackle extreme heat? Thank you.
So I think for that, I would invite other panelists to also talk about, green space, because you guys talk about.
Yeah, okay. So make sure this is actually on. Thank you for the question. I think one of the things that some of the research in the mental health space in particular is identifying is that you don't necessarily need vast, large areas of green space within the city to provide these benefits. They can be small. There's some research that has even shown that simply being able to look outside of your window and see a tree, a piece of green can have benefits in the physical space as well as the mental space. And so I think, obviously we would much prefer there's larger spaces that are green than just a single tree, but there is benefit that can be there even from those small amounts. So I think there is opportunity even in these urban spaces to be able to provide small amounts of greening and work toward a more integrated city with mixing the gray infrastructure of the city with the green infrastructure.
Just as the case I have shown that we also organized the plant library for the populations, and that was only a very small little plant, a pot. And so, but the residents they gave feedback to us and saying that they love to see that plant inside their small apartment. They feel like more relaxed, and they can take care of the plant, and they are like doing something for the environment. I think that sense is also very important.
Yeah, just one small addition. I think Hong Kong does not lack green spaces. There is also the issue of accessibility. So it was touched upon one of the presentations. So some community has issue having access to those spaces because of transportation costs, so because of economic reasons. But some communities might have issues also because of social issues, social identity. So perhaps facilitating the accessibility to green spaces is also something to keep in mind.
I just want to add on that one, just to give us sort of a much more rounded and comprehensive perspective with regards to this one. Because access in one thing, and transportation access in particular, but maybe also there are social dynamics also that prevent certain groups of people not be able to access green spaces. So for example, it could potentially be, although I don't know really the context of Hong Kong, but I know that in some areas, in some places in Southeast Asia, some women cannot just step out of their households because of the number of domestic tasks that they have to do for the households. So that alone is an important concern, that to have to really understand, why certain people are not able to access green spaces, because even if you provide, for example, the transport network, you lower the cost. If socially there are pressures on them, then maybe they're not actually able to partake on that green space.
Yeah, just to add that, we actually just concluded a project that has been funded by the Robert H. and Ho Family Foundation of Hong Kong that look at deviations in terms of how Hong Kongers think about sustainability and whether there were changes in their sustainable behaviors before and during the pandemic. And we found that going to public parks, going outside and accessing this actually increased during the pandemic, and it improves Hong Kongers' mental well-being. We have published about 2 papers on this in this topic, and I encourage everyone to take a look and check these recently published papers.
So you have to answer.
So for the first question, whatever they said, I agree with them totally, especially on the point on the inclusivity aspects. There's that fixation on technological or engineering solutions, but we need to put the community, you need to put the people first in that sense. The inclusive elements, your talk on the exposure on the subdivided apartments, that was really an eye-opener. It really speaks to the heart of why we need to reduce risk accordingly. So, pardon me, the second question on whether there are other aspects that can be done apart from the importance of green green park, green spaces. Not from Singapore. I would pick a few. One is we know the importance of street trees, green spaces, expanding the size of that, making sure there are public spaces for people to play and work and enjoy the cooling that provides there. Other evidence from a multitude of case studies elsewhere showcase a few important themes. You can have good urban design. You can have the importance of reducing emissions from cars, for private vehicles, promoting public transportation, which has a co-benefit of reducing greenhouse gas emissions as well. When I came here the last time, I remarked at dinner last night, growing up and visiting Hong Kong as a kid, I was told by my parents, this city has the highest concentration of Rolls-Royce cars in the world, per capita. We've come in and we noticed when we were traveling from HKIA to UST, the high degree of Teslas, the high degree of BYDs, the high degree of electric vehicles that have started to permeate here. It's a good thing, I would say, moving away from petrol, moving away from diesel that adds on to waste heat, that drives the urban heat island, one of the key drivers of the urban heat island, is a good thing. Maybe that might be the future. We can say that Hong Kong might have the highest concentration of electric vehicles in a major metropolitan area. But I will want to also add, all these solutions, as I said, they are well known, but you really need to incorporate the best scientific information in determining the policies for reducing your exposure to extreme heat. In this case, Hong Kong has a fantastic group of scientists, has a fantastic HKO that provides you with all that information. And it will be essential that colleagues from UST and other Hong Kong universities, we learn from them in Singapore and vice versa. It will be important to leverage this academic capital in order to determine the best policies that can benefit the vast majority of people who work, who live, who play here in Hong Kong. Okay.
Hi, thank you so much for sharing. So I'm Joanne from AXA Climate as well as HKUST. So in Hong Kong, I can see that there are already existing cooling strategies implemented for buildings. For example, like building green infrastructures or like green roofs, reflective service. However, I can also see that considering more frequent and also intense extreme weather events, these cooling strategies might not be that effective. For instance, like one example could be that typhoons damaged green walls or like green roofs and uprooting vegetation, which increases the maintenance as well as repair cost in terms of a business perspective. So in light of these situations, what would you advise in terms of like what kind of adaptive cooling strategies would be most effective and also feasible in Hong Kong in terms of a building perspective as well as a business perspective? Thank you.
You may not have that, but anyway.
Okay, so I'll give the floor to Cho in a second, but so especially considering the, let's say, the interaction between nature-based solution. I mean, nature-based solution can also have some side effects that needs to be taken into account. I'm not an expert on that, so but yeah, I guess that is an important point. I think it's also important to keep in mind that we don't have like fit-for-all solutions. I mean, the solution that have been presented and discussed also need to be applied to the context, to the specific context of a place. So Hong Kong has certain characteristics, so you might actually want to think about other strategies. And for example, if I may actually, I mean, in a place in which you use a lot of air conditioning, a simple strategy that can also increase your resilience in terms of power system, reduce your energy bills, is to increase the set point of air conditioning. Just 1 degree, so say 26 as opposed to 25, would save between 10 to 15% of your electricity bill. So, sorry, I didn't really answer your questions because don't have the answer, but maybe someone else.
But it's an important answer that applies to not just Hong Kong or in Venice or even in Singapore. There's a whole push now in increasing the set point of temperatures that reduces waste heat. Air conditioning applies on the principle that you transfer the heat indoors, outdoors. We enjoy the benefits indoors. People outside and pedestrians, they don't. So that's one thing. But to your question about good urban design, other ways that can benefit people and businesses, one common thread that I've seen from the context of tropical cities, even though Hong Kong is subtropical, architects, landscape designers, planners should look back into history. People have lived in tropical areas for a very long time. There are lessons that can be applied. So in Singapore, if you've been there, it doesn't have any wind speed. It's hot, it's humid, you feel very uncomfortable. How we incorporate urban design is to have big void spaces at pedestrian level. It's built based upon the historical Malay archipelago architecture of building houses on stilts. You remove away, any obstructions at pedestrian level. You allow wind to pass through unimpeded. The work that we've done, and Peter was a part of Cooling Singapore as well, we looked into the impact of shade. Shade is an extremely important factor in tropical areas to reduce thermal discomfort, reduce your exposure to heat. So you do that in combination in new buildings, or old buildings. You can stick with the air conditioning example. But if you're designing new buildings, look to what our forefathers have done in the past and see how that can be applied in order to reduce your exposure to any extreme heat issues. Then other sorts of things that we've done for newer skyscrapers and looking at the design out there. One thing that we've done in the new financial center in Singapore is we use the analogy of a sail. So you have staggered skyscrapers of different heights. So one short, one medium, one tall, short, medium, tall. It functions like a sail in capturing cleaner air and wind from the boundary layer, the upper part of the urban canopy layer where there's no blockage. It funnels it down like a sail to pedestrian levels. It not only helps with the comfort of pedestrians walking around at the street, but the increased wind removes away air pollution from cars, buses, and trucks that goes around the roads. So again, this is an old principle. The idea of looking back and seeing what historical principles of design can be applied here it's universal, but it will be very effective for a place like Hong Kong.
Hi. My name is Dane, and I'm a climate change consultant. So I work for IBIS Consulting, and I just want to share a story that, two stories actually. It has to do with extreme heat, because we do a lot of our work in the Philippines. So 2 weeks ago I was there, and we were doing some wind farms. And we saw people, working under like 40 degrees Celsius heat, like doing construction, right? And we also have another client. They do retail and warehouse, and they're a big client. And one of their biggest problems is heat-related stress for their workers, right? They have like a lot of headaches. They have like a nurse that came in and say, "Oh, our biggest problem is heat-related health issues," right? And then, so my job as a consultant is I have to look at the climate change risks and then come up with solutions. Right, and one of the solutions for that retail house, that retail center that I suggested was, okay, then maybe we can look at reducing, moving the work hours, like reducing work hours. And my boss was like, Dane, this is the craziest thing you've ever suggested. Like this doesn't make sense financially, right? So my question is like, how do you communicate to maybe like the finance or like industry people like us, that adaptation solutions for extreme heat is a good business practice? Like, how do you communicate that? Because first of all, it's really hard to talk to like CEOs or like these finance people, because they stay in air-conditioned rooms every day. Like, how can I tell them, oh, your workers outside are working at 40 degrees Celsius heat, right? And it has to do something a lot with like the compassion that Dr. Albert was saying. Like, how do you make an argument for compassion in a business sense? Because like this is really difficult. Like how do you make that balance? So this is my question to anybody who wants to answer.
You set policies, and industry has to comply with policy. That's.
I wonder though, when you presented your options, did you look at the cost and benefits of all the options? So in other words, you cost everything. Because I would have imagined if you just say, shift the hours, the working hours, immediately I think there's an immediate reaction. But if you say, if you shift the hours, these are the amounts of savings you're going to get in terms of productivity, health costs, and other things, then they can see, for example, the differences. Then maybe it would have been a much stronger argument, because maybe your boss would have been looking at, bar graphs or whatever graphs that can actually inform that decision. So maybe speaking his language would have actually helped communicate your message.
To add on that, there's actually an ongoing discussion on 4-day work week in the US and in Europe. So probably, that can be considered and think about. So I'm Filipino and I grew up in a farm, and my parents, who are farmers, they start work at 5 in the morning, go home at 9, have rest, and enjoy siesta and go back to work at 3 p.m. until 7 or 6 p.m. So maybe instead of changes in working hours, maybe staggered work hours can be a solution, especially for outdoor workforce.
Well, I was also going to mention the siesta, but from the Spanish perspective, where it is culturally normative that the banks close, the businesses close in the hottest part of the day, and then they work a few later hours. That is going to require a cultural shift, though, to accomplish that. But I think you can look to other cultures and other places to see these types of activities working. And we're already in a globalized society. We're all working with people whose hours are the exact opposite of ours. So it's not exceptionally unusual for us to be working outside of the standard 9 to 5. We just shift when we're working and adjust accordingly.
Fully agree with what was said. What Albert said as well about cost-benefit analysis. It resonates when we communicate with... that's something I learned in the past 5 years in my job in the management university, talking to a business community, and dollars and cents oftentimes gets more resonance than just a more persuasive moral or cultural argument, even though I fully agree with what was said about that. A more interesting, relevant, local in the sense of Singapore example. I hate wearing suits, despite the fact I'm wearing one right now. In Singapore, there's a push towards not just the 25 degrees Celsius air conditioning for officers, but now we want to promote wearing ethnic local culture. So yesterday, Laurence and I, we were wearing batik shirts. I love my batik. When I attend UN conferences, it's formal wear. So it also makes me stand out. And the more important thing is that it's much more comfortable compared to wearing a suit, which is something we in both Singapore and Hong Kong, we share that same British colonial heritage. Everybody has to wear a suit. Why not wear something that is also considered to be formal wear and then adapt accordingly? Not only does it make sense for, if you link that with your warmer set points for air conditioning, you have the cost-benefit analysis, saves money, reduces carbon emissions, but it also has a sort of local pride thing going on in that sense. You develop your own identity, and it's been taking up. So as part of the Singapore Green Plan, my friends in the Ministry of Environment and Sustainability, every Friday they get to wear their batik shirts as opposed to their suits, which less colorful, much thermally uncomfortable, and boring to look at.
Okay, maybe last two questions. Okay, free.
Thank you, all speakers. I'm Will Lang from Mingbao, and I would like to ask more about the solutions to workers or vulnerable workplace. Like in Hong Kong, we have construction workers that always work under the sun, and we recently have that heat stress warning system in Hong Kong, but has been criticized for not frequently raising that enough. But I want to ask, any speakers that have experience and wisdom to share with Hong Kong that the government can learn from. Thank you.
Quick on, if you don't.
I can only add one story to the suggestions that were discussed before. In the Cooling Solution Project, we documented alternative solutions around the world. For example, in Brazil, there are places where the construction sector works at night, so there are night shifts for certain types of jobs.
Maybe I don't really know much about Hong Kong, so maybe this is also a question, so I'm not sure whether this is a response. But also asking the questions whether, who are those construction workers? Are they migrants? Are they entitled to health benefits? Do they have social protection? Because maybe by asking all of these questions, we know already their vulnerabilities and what are the opportunities for them. Because maybe just by being migrants and then do not have health, benefits, then that by itself could already know. We know already that if something is going to happen with their heat or anything, they're already going to suffer. So maybe just asking those questions could help us get to the answer.
Fully agree with Albert. In Singapore and in most other rapidly developing cities, the outdoor construction workers are mostly migrant. Depending on, they are extremely exposed. They have very little sort of capacity to adapt. You can look into an example of I like my football, the Qatar World Cup, where all the stadiums were predominantly built by workers from South Asia and also from the Philippines as well. So understanding the vulnerabilities of those communities is the first step. Second step is that there is good examples from other places in terms of reducing the exposure through a combination of physiological factors and heat warning systems. In Singapore, there's work done concurrently with colleagues in the National University about what's the best way to cool the core temperature of people, who work outdoors. What they found initially is a combination of a slushy, a slurry drink, ice and water, works to reduce the core temperatures much more quickly than water or ice alone. Second is that for the governmental side, for the policy side, there has to be some teeth in terms of protecting the most vulnerable. And what's been done in Singapore is that the Ministry of Manpower and looking into the sort of health, environment and safety issues, companies that ignore warnings from under WBGT, it exceeds 33 degrees Celsius in WBGT, work stoppages have to take place, people have to go under shelter, people have to have, workers have to access to cool, shaded areas, to drink, replace fluids. Companies, and the penalties are, if companies don't follow up on that, they get fined a lot of money. First one, I think, is about 10,000 Singapore dollars, so that's quite a fair chunk of change in HKD. And the construction firm, those who are in charge, can get jailed. So there is that teeth to that aspect to make sure that the rights and the sort of safety and the environmental justice aspects are taken care of. But that's one example in Singapore.
Okay, maybe we just take both questions together.
Thank you. Edwin now from a local green group, the Green Earth. Hong Kong, especially the urban area, from a concrete jungle, now turning into a glass jungle. You see all the buildings, in the past it's concrete, now it's glass panel. And is it possible in terms of the technologies that to turn our glass jungle to green jungle, or a hybrid, even they are made of concrete or glass, then to integrate the vegetation into these buildings so that, I read in different journals saying that vegetation or a tree is like a electricity-free air conditioner. So if we have many of these electricity-free air conditioners set in our concrete jungle, glass jungle, it will reduce our ambient heat, and especially to reduce the urban heat island effect. And is it really possible in the country, the city where you are from? Is it a solution? Thank you.
Okay, hold. Can I get that question over there? Yeah. First.
Hi, sorry. Hi, my name is Rebecca. I'm from Aon. I'm an insurance consultant. Anyway, but effectively, it's a bit not quite related, but more related to the lady before asking the question in terms of how to adapt from a corporation perspective. So a bit of a comment and question here from my side. I feel we have to engage the corporations and the business in the adaptation process, and we need to have enough incentives and opportunities out there illustrated to them that they have to make this move, and there is benefit, there's tremendous benefit in making the move and tremendous cost if that's not going to happen. One addition from my side is that we do have a team, not my team, but I think it's quite applicable. Extreme heat is very difficult, it's very abstract. It's not like climate, typhoon, property damages, so on and so forth. It's very difficult to convince them, but we do have a team that work with companies on their talent compensation, the employee compensation schemes, how to build the well-being components, build a mobility component into that, because some of these clients actually recognize the long-term cost if this doesn't happen with them. So, costing productivity, costing profit, costing revenue, going on. But this is not the norm. Like, we are still seeing that a lot of business not recognizing this. And turn to, I can't remember, sorry, one of your comments. There are opportunities too if they switch. So like Tesla, the BIDs, the kind of, if we adapt early, this early adapter having an advantage on this. So I think in general, there are a lot of ways that business has to be engaged. But I think it's still a minority at this stage because of how we are at sort of chronic risk is a bit difficult to measure the impact on. So how have you seen, maybe in your respective countries, has been able to engage the corporates a bit better, move the needle a bit better in this sense?
Good question. Green building, really green building, and the business sector, how to engage.
I guess I can start and say, I think this may be just a bit of them. If you have sufficient water availability, green walls, green roofs can be quite useful. But they're also going to speak to the corporations, they're going to reduce your overhead costs because you're not going to spend as much on your heating, ventilation, and cooling. So that applies across the entire season, not just the summer months. So that can become a benefit to the community, but it can also address some of the corporation's concerns and save money there while not in benefiting them in terms of raising the revenue, maybe being able to redirect those funds toward other initiatives that might help the workforce or address larger scale climate issues.
The thing with some of the corporate or commercial approaches to responding to disaster risk is that they tend to be oriented towards sudden onset events. That's why there are no products and services for slow onset events, of which heat wave is an example, because it's really hard to define the trigger, the target. But I think in other countries and other places, they've already explored, the use of first loss mechanism, like to cover a company to develop certain products, right? Because one of the key factors why they cannot develop the product, because they don't want the first loss, right? So if someone is going to take on the first loss, maybe say company or a donor or a particular organization or entity, then maybe it could encourage to develop that. So I'm not sure, maybe the question would be, what is in the context of policy that can actually enable for an entity to cover the first loss? And then maybe learning from the experiences of other countries wherein a particular investor is actually willing to front the money for first loss mechanism. So maybe that could be, an option that could be explored in this context.
There are just a lot of stuff to be unpacked from the question, but I really would like to remind everyone that Hong Kong actually wishes to establish itself as a world green city, a center of green finance. And there is now an investment appetite on sustainable investing, services and products that are sustainable, are labeled as sustainable. So maybe incorporating extreme heat with ESG. I don't know whether it has an E or an S or a G, or maybe all, right? I don't know really. So maybe there's an opportunity there. Yeah, but I don't know what. Yeah, maybe that's something to be explored on. Maybe you have a response, Winston.
I hope I have a response. So quickly to Mr. Edwin first. Actually, it's a common answer for both. It's a question of demand and supply. The technology for green buildings are there. Victor has mentioned that well. Lots of other green examples. You've been to Singapore. You've seen the green walls and green roofs for not just hotels but also for public housing. It's there. It's embedded in our in the culture. But in order for that this nature-based solution to be successful, there needs to be a sustainable demand for that. There needs to be consumers or a public that demands that you need to have these green spaces as part of or integrated within your urban design. It's easier said than done. I've come across pushback from people who obviously they like yourself, they see the value of green spaces and they want that fully embedded in the city. But I was mentioning to some of the panelists in Singapore, in some landed properties, so bungalows and terrace houses, there's been a significant pushback against green infrastructure. Why? Because when you have trees that provide shade and provide cooling, the co-benefits are that there are birds. And if the birds nest in trees and you've got rich people with cars parked underneath those trees, what happens? So there's that pushback against that for that inane reason. Okay,
Go ahead.
Lastly, so demand and supply. Make sure that there is that demand to match that technological and other supplies for green buildings. For the question on whether or not the other industries, the private sector can take up on that, fully agree with what was said earlier. There's now a push. I mean, firstly, can this bearing of loss or cost be dealt with a partnership with the public sector, with governments? Some more progressive cities have done so already, focusing on adaptation. It can be done. But secondly, on that theme of demand and supply, in the long term, right now in many cities, there is that pivot towards sustainability financing in ESG. There is that big push in places like Singapore, the sort of demand for courses looking into carbon accounting, into making sure that you can articulate both the physical risks and the transition risks in my school of accounting, for instance, is very strong. In the long run, that leads to a bigger consumer base, that will lead to a bigger demand for making sure that those risks are properly accounted for, and then we can then hopefully have that stronger push in the private sector for these sort of ESG initiatives.
Okay, I have to take your mic because I have been told for some times that we are running out of time. But I actually think, as the moderator, most of the questions I prepare and get them, we have answered. But there's one thing I actually want you to comment on. Really, because adaptation is a little bit different from mitigation. Adaptation is very, very local. Different place where you can do in one place may not be suitable for another place. And I think there's a lot of potential as well as challenge here. How expert policymaker as well as local community can work better within and across border to cool city or deal with other adaptation issues. So the question is there any model or framework that you think going ahead can get this done better? Okay, so 1 minute for everyone, because you all read this question before.
I just want to make it quick, right? Right. Surely there is no model for us, but as what I mentioned, I think very importantly to us, our rationale is to get people engaged. It's not only the community, so community is part of it. So we believe in their wisdom, we believe in their capacity, but at the same time, we also need to realize what is actually facing, and then by recognizing all of these risks and potentials, and then we also connect with all different kinds of stakeholders and come out with a solution that agree by amount of all the stakeholders. So I think community participation and the community I mean is all the stakeholders.
Yeah, I would echo that. I think the only other thing I would add is when we're talking about contextualizing things, geography is the discipline of understanding space and place. And that applies both the physical space and place as well as the human, social, cultural space and place. So advocating for geography and the humanities to remain a part of our education systems rather than focusing exclusively on the physical sciences and mathematics. We need to understand those socio-cultural dynamics that geography does a great job of communicating.
Yes. On top of that, so sharing knowledge, but also sharing practices and transfer the practices that can be transferred. So it's true that there are many things that are local specifics, but there are also many things that can be transferred. And for me, for example, this workshop was like it's an amazing opportunity for me from Europe to learn things that are being done in Singapore, see that there is a collaboration with Red Cross doing certain things. We are also collaborating with Red Cross through Italy, so I can go back. And so I think this is one part of our job.
Yeah, I think what we all wanted to say is that we need to act in solidarity with vulnerable groups, communities, and other stakeholders in response to this particular challenge.
Yeah, so to add on that, human-centric development that has a nod on environmental justice, recognition of the most vulnerable in society.
So, 30 seconds. Fantastic to focus on the human element. There's great knowledge to be shared, not just from one city within cities, but across cities on what is the best practice. But I want to point out two other things. One is finance, and the other is regulation. You need to have business communities buy into this. You need to have people who understand there is money to be made. The opportunities are there for a green economy. The opportunities are there for it to be sustainable. It takes time for that to develop, but with the sharing of knowledge, if people are on the same page for that, it works. Secondly, regulatory capacity as well. Governments, lawmakers need to support the business communities, support startups, support SMEs in order for them to thrive. How can policymakers work with them to make sure that all the ideas that we have here to reduce climate risk, to improve adaptation, can be successful?
Okay, actually I would answer the question to say, challenges are opportunities. Well, I think most people in Hong Kong are quite used to that. And I actually think that if you go back to think about COVID, actually COVID shows us that a lot of things you don't think it will ever be done has been done. When there is sufficient challenge, it will force people to act. Whether we want to act kind of being the leader or we just follow, I think that is the question. The next thing is even the news that we get today about how bad it's going to get is actually telling you that the challenge actually will be coming, whether you believe it or not. So all the things that we are talking about are opportunities. So from the bottom line perspective, because we really believe that if things cannot be financially justified from a corporate point of view, with some government persuasion, that it couldn't work very well. But actually, the solution has to come out when you look down the road. And I see that humans are very adaptive, and we have been able to deal with heat, extreme heat, in many places without electricity. People survive without electricity for 20,000 years. So how do we actually get back to doing things, learn from the past? I think is something we have to get back and learn. So on that note, I thank everyone here for joining us. And we will have more of this later. We hope to see you all in the next event. Thanks very much.